Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's very easy puzzle, and it's called Nab Nab Sum Sum by Flinty. And here are the rules. Normal Sudoku rules apply, which means place the digits 1 through 9 once each in every row, column, and box. X sums, diagonal. Clues outside the grid are the sum of the first X cells in the corresponding diagonal. So it's always diagonal. Interesting. Where X is the digit in the cell nearest to the clue. Digits may repeat within a sum. So, for example, this says 19. If this were to be, this could be 5. If this was 5, that means the first 5 cells add up to 19. If this were a 4, though, that would mean the first 4 cells add up to 19 here, as an example, along this diagonal. And that's the same for every diagonal, right? So whatever the first cell is, that tells you how many cells along the diagonal to add up. And that's what X sums are. Normally it's within a row or a column, but yeah. Anyways, Nabner lines. Digits cannot repeat on a golden line, and lines cannot contain consecutive digits regardless of order. So basically, if you had, say, a 3 on this line, you could not have a 2 and a 4 on it, because that would be next to it consecutive. And again, Nabner is basically the opposite of Renban, which is Nabner backwards. So therefore, that's how Nabner got its name, because it's Renban backwards. So it's the opposite of Renban, or the backwardsing. That doesn't make any. That's not a word. It's basically, yeah, the reverse of Renban. So you cannot on a Nabner line have repeats, and you cannot have consecutive digits on a Nabner line. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay, so for a Nabner line, obviously these diagonals cannot be 1. None of the diagonals can have a 1 anywhere on it. Because, yeah, it adds up to more than 1, right? The 11s could have a 2 on it. That's it, though. So this could be 2. These could be 2. This could be 2. They could also be 3, but they cannot be 5. So this is 2 or 3, this is 2 or 3, and this is 2 or 3, and this is 2 or 3, which means 2 or 3 cannot be in any of the rest of row 1 or column 1, because we have a 2-3 pair, right? So it's either 2, 9, or this is 2, 9. So whatever is here is not here, which means this is the red, and this has to be green. The 2 has to be with a 9. So one of these is 9. We don't know which. So either this is 2, 9, or this is 2, 9. 3 could be multiple things. Wait, no, this doesn't work. I see. Okay, so that cannot be 2 and 3 then. We know these actually could be 4. Right, it's 2, 3, or 4. Actually, it could be 5 even, right? 5, 1, 2, and 1, 2. Oh, yeah. I'm sorry. I'm too used to X sums being on a row or column. So this doesn't actually have to be 2 or 3 only. It could be 2, 3, 4, or 5. Right? Because it could be 5 with 1, 2, 1, 2. That would make 8 plus 1, 2, 1, 2. Right. This is 39. the most this could be, so yeah, since that, okay, so this is 2, 3, 4, 5. I think that's, well, okay, so for these, that's the extent of these diagonals, right? These diagonals, however, could be, can it be 6 is the question. If it's 6, you could have 1, 1, 1, 2. So 6 plus 1 is 7, plus 1 is 8, plus 1, 2 is 11. No, so this cannot be 6 either. This is 2, 3, 4, 5 also. 5, 1, 1, 1, 3. Yeah. Okay. This is at most 5, 7, and 9 because it's an Abner line, right? So it's 21 at most. Oh, what is this? Oh, okay. Another thing is this has to be 1, 3, 5, 7, 9. Because you can't have repeats. So since you can't have repeats, they have to be non-consecutive too. The only thing that actually works on a 5-length Nabner line is the odd digits 1, 3, 5, 7, and 9. Because they obviously you can't repeat, and then you can't be consecutive. So if you ever have an even number, that's consecutive with an odd number. So therefore, this has to be 1, 3, 5, 7, 9. So this adds up to 25. Always. Right? And since it's 20, this is also 1, 3, 5, 7, 9, because this is also an Abner line, which means this is 2, 4, 6, 8. So this is 1, 3, 5, 7, 9, which means 1 and 9 add up together, it's 10. 3 and 7 add up to 10. 5 adds up to 5, so this is always 27. So 25. Therefore, it has to be more than 5 here. So this has to be 7 or 9. Can't be 9 because then that would be 1, 1, 2, 3 at least. So that would be 25 plus 1 plus 1, 3, and 5. Or 1, 2, and actually, it would have to be 1, 3, and 5 at least. So that, but that just doesn't work. So therefore, this has to be 7, which forces these not to be 7. So therefore, this has to be a 1, because it has to have 7 digits, which add up to 27. We already have 5 digits, which add up to 25. So this has the next 2 digits have to add up to 2. So this is 1 and 1, which means 1 cannot be here. 1 cannot be here. 1 has to be one of these 3. We have a certain amount of digits adding up to 39. This already adds up to 27. So these 2, this is 7. So say it was only 8 here. If this is only 8 here, this would be 1, 3, 5, and 9, which adds up to 18, 19, 20. And then you have 28, but then this digit would have to be greater, so this has to be 9. So then the full diagonal here must add up to 39. And we already know these 7 add up to 27. So therefore, these 2 must add up to 12. So this must be a 3. This can't be 3 then. This can't be 9. So the 9 is one of these 3. There, and the 3 is one of these. Well, actually, that could be 3. So this can't be 9. This cannot be 9. This is 3 or 5. This can no longer be 1. So this is, if this was 5, this would be at minimum 1 or 2 and 3. So this would be 5. And this could be, this would have to be 5, 1, and 2 at minimum. But that doesn't work, right? Oh, in addition, this is a full Nabner line. So it can't be 4 and work correctly because you can't have repeats. So this could be at most 4, 2, and 1. But that doesn't work because, yeah. Then what is this? This is 4, right? And 1 and 2 are next to each other. So this is at minimum 135, but then it has to be with a 2, right? If it were to be 4 or more. Actually, yeah, it doesn't work with a 4. It doesn't work with a 5 either. If it's 5, this would have to be 1, 3, 5, and 7 at minimum. So this can't be 4 or 5. This can't be 4 or 5. Yeah, so I was right there for this is 2 and 3. This, however, cannot be 2 and 3. Therefore, one of them has to be 4 or one of them has to be 5. We don't know which. This is 2 or 3. This is 2 or 3. Does that make sense? I hope. I mean, because basically, if it's 4 along the line or 5 along the line, the minimum you can have with 4 is 1, 4. Because of the Nabner line properties, you can't have repeats and you can't have consecutive numbers. So 4 eliminates 3 and 5 from being on the line. You can only have one of 1 or 2 because you can't have both. So you can only have 1, 4 at minimum, then 6, then 8. So that would be 4, 6, and 8, which adds up to 18 plus 1, which would be 19. And that's already greater than 11. So 4 cannot be there. 5 can't be there for the same reason, but you could have 1, 3, 5, and 7. But that adds up to 16, which again is greater than 11. So that can't work for the Nabner line. We know this is 1. So 1 has to be one of these two. I'm not sure which. This can't be 1 then. Can this ever be 5? If you have 5, you would have to be with at least a 2. So 5 and 2. If you have 5, 2, this could be 1, but then this would have to be 2 and 3. Right? So 5, 2 is 7, plus 1 is 8, plus 2 and 3 is already greater than 11. So this can never be 5. Therefore, we know this has to have a 4. It can't be 2, 3, 2, 3 because it's consecutive. So it has to be 2 and 4. So one of these is 4, one of them is 2. So 2 always is with 9 to add up to 11. So 9 has to be one of these two, which means this cannot contain a 9, which means where is the 9 on this Nabner line? There has to be a 9 because it's 5 in length, therefore this is a 9. So this cannot be 9 here, this can't be 9. This can't be 9, this can't be 9. So one of these two is 9. The other one's 4, and it cannot be with 1 or 2. It could be with 3, so it could be 4, 3, 1. 4, 3, can it be 5? 4, 5, 1, 1 would have to be the case, and that's not possible. So 4 has to be with a 3. So this is a 3, 9 pair. So this can't be 3, right? Because we tried it with 5. 4, 5, 1, 1, but the 1 is already here. So this can't be 1. So it can't be 1 and 1. Therefore, this is always greater than 11 if this is not 3. So therefore, this is 6 or 8. This is 6 or 8. So it's 4, 3. This cannot be... We don't know which one of these is 1. Does it have to be a 1 is the question. It could be 4, 3, 2, 2. That does seem possible. So if this is 2, this is 4, and that has to be 2. So 2 is always one of these two cells. So 2 cannot be in the rest of row 1 or the rest of column 1. Because we know if this is a 3, this has to be a 2. Actually, they both could be 3s. Never mind. They don't have to be a 2. Never mind. It could both be 3s, right? That also works. That seems fine. Yeah. It just has to be a 2 or a 3, but we don't know which. It could be 4, 3, 2, and 2. That is possible in both sides. So if that were the case, then this could be 1. What's the most this could be? 2, right? If it's 4 and 3, it's either 2. Oh, it could be. No, it could be anything, right? Because it could be 2 and 9, right? It's only if it's 4 that it limits things. It could be 4, 3, 1, 3, right? If this is 3, it would have to be with 1 and 7. Oh, that's actually interesting. So if this is 3, it has to be with 1 and 7 because we need 3 digits that are not consecutive. So 3 can't be with 2. If 3 is with 5, that just doesn't work because it would have to be with 3 again. So 3 could be with so we tried to avoid 3 being with 1, but that doesn't work. 3 can't be with 2 or 4. So, and 3 with 5 doesn't work, so therefore it has to be 3, 1, and 7. So this would have to be 3, 1, 7, or this is 3, 1, 7. If it's 2, it has to be with 9. So if this is 2, this is 9. Or it could be a lot of other things. If this is 3, and this is 1, and this is 7, okay. It cannot be both 2. If it's both 2, obviously then neither of these can be 2, and therefore it'd be 4 and 4, which is an impossibility. So at least one of them has to be a 3, which means it has to be 3, 1, and 7 in one of the cases. Therefore, this can never be a 1, because either this is 317 or this is 317. In both cases, both of these ones see this cell. So therefore, this can never be a 1. So this is a 5. This is a 1, which forces this not to be a 1. So therefore, anything that comes with a 4 and a 3, it must be 2 and... Okay, this can't be 5. This has to be a 3 then. So this can't be 3. This can't be 3. This can't be 3. Therefore, this is a 3 because you need a 3 on this nabla line. Therefore, this can't be 3. This must be a 2, which forces this to be 4, which forces this to be 2, which forces this to be 3, which makes this a 1, and this is a 7. So the 2 has to be with a 9. So this is 9. This is 9. We don't know what this is. This must be a 3 then. This is 4 and 3, and it has to be with 2 and 2 because 1 is no longer allowed. So this adds up to 7 plus 2, that's 4. Therefore, that's 11. So this is 2 and this is 2. So this cannot be 2 and this cannot be 2. This can't be 4. This can't be 1. This can't be 1. This can't be 9. Therefore, the 9 can only be on this nabla line here. We know the 2 has to be here then. So this is one of these is 2. Let's see. So this adds up to... This can't be 2, 1, 2, 3. It could be 4, 5, maybe 6. Let's see. This would have to be at least 3. 3, 2. So I don't even think it could be 5 even, right? 5, 2. This can't be 1, so that would be 2. 5, 2, 2, 4. So yeah, it can't be 5 even here. So this has to be 4, right? If we have 5, this is at minimum 2 and 2 and 4. 2, 2, 4 add up to 8. With 5 is 13. Yeah, I don't even know if that works. So say, okay. So this has to be either 2 or 4. This can't be, yeah, so this is either 4. If this is 4, we tried to make this a 6. This is 2, 4, 6. 4 with 6 and 2 and 4 is already greater than 14. So this can never be 6. This can't be 4 even. If this was a 5, we tried 5, 4. This would be 2. This is at minimum 4, and then that would be 2. So 5, 4, and 2 is 11, plus 4 and 2 is 17. So 5 never works, so this has to be 4, which makes this a 2. So this can't be 2. Therefore, this is a 2. So we have 4 and 2, therefore these two must add up to 8. And the only possibility that works now is 4 and 4. So this can't be 4. This can't be 4. So this is 5, 6, 8. Because it can't, and because it's a 6, 8, 6, 8 pair in box 4, there cannot be a 6 or 8 in the rest of the cells. So this is a 5. Because it can't be 9. And that was the only other possibility besides 6 and 8 and 5. So therefore, this is 6, 8 with 9. This can't be 9 either. So therefore, this must be a 9, which makes this 6 and an 8. This can't be 6 or 8, so therefore this is a 5. This has to be a 6 or an 8. So that's done. This is done. This can't be 1, 3, 7. It could be 5. It can't be 9. It has to be 5. Can't be... yeah, no 1, 2, 3, 4. Could be 5. Can't be 6 because that's next to a 7. Can't be 8 because that's next to a 7. And can't be 9 because the 9 is already there. Therefore, this is 5, which forces this to be 7, which forces this to be a 1, 5 pair. This can't be 6 or 8. Can't be 1, 3, or 5. So this is 7 or 9. Can't be 9, so therefore this is 7. What's the rest of column 2? It has to be a 3 here. This has to be 1 and 9, so this is 1 and 9. This is 6 or 8. This is 6 or 8. This can't be an 8 because of the 9 on the Nabner line, so this is 6, this is 8. This cannot be 1, 2, 3. It could be 4, can't be 5, can't be 6, can't be 7, can't be 8, so this has to be 4. Let's see. These can't be 2. This can't be 2. So 2 is one of these two. Nine has to be one of these two. Neither of these can be 3, so therefore 3 has to be one of these two. This can't be 3, this can't be 3, this can't be 3, therefore this is the 3. This can't be 3, therefore this is the 3. This can't be 3, this can't be 3, these two can't be 3, therefore this is 3. And I think we have all the 3s now, right? Yep. 4, it's pretty limited. So this, okay, so this is 1, 6, 7, 8, right? So this can't be 6 or 8 because of the 6, 8 pair here. So this is 1 or 7. This is 1, 6, 7, or 8. This can't be 7 here. This could be 1, 6, 7, or 8. That's fine. This has to be 5, 6, 7, or 8. This is 5, 6, 7, or 8. Because that's all that's left in row 3. This can't be 8, obviously. So this is 5, 6, or 7. This one cannot have a 2 or a 3 or an 8. Oh, this can't be 1. So 1 can't be here, 1 can't be here, 1 can't be here. 1 has to be one of these two. So 1 is always in here. Can't be with 3 or 4. Sorry, can't be with 2 or 3. So you can get 1 of 4 or 5, 1 of 6 or 7, and 1 of 8 or 9. But 8 can't be here, 8 can't be here. Therefore, you always need a 9. And 9 cannot be here, so therefore this must be 9, right? Because we know you can have 1 of 4 or 5 on this 4-length Nabner line. We have a 1 already. There's no 2 or 3. You could have a 4 or 5. You could have a 6 or a 7. You could have an 8 or a 9. You can't have an 8, though, because this is eliminated by here, and therefore this is eliminated this way because of the 6-8 pair. Therefore, the 9 has to be on the Nabner line. So, and the only place for it is here. So this can't be a 9 now. Therefore, this is 9. This could be 1, 5, 6, or 8. This could be 1, 5, 6, or 8. But it can't be 8 specifically. We know 1 is on the line. You can have 1. You can have a 4. So it could be 4, 6, 4, 7, or 5, 7. Right? So this is... if it's 6, that would be 6, and this would be 4, and that would have to be 1. It could be 1, 4, 7. This would have to be 1, 4 with... This could be 1 or 4, and this would have to be 7. So this would be 7, 1, 4. If it's 1, 5, 7, either of these could be 5 or 7. So this could be 5 or 7. So that works too. Let's see. This has to be 4, 6, or 8. So this is 4, 8. These are 4, 6, or 8. So the 6 has to be here. The 6 is one of these two. Okay, so this must add up to... Oh, this can't be 1. So therefore the full amount must be 5. So this, that was 5 and this is 1. This can't be 1. It can't be the full 5 either, because we know the full 5 adds up to 19. So this must be just 4. Right? Which does add up, right? If this is... So this is 5, this is 1, this is 4. These two must add up to 9. So since this is 4, it's with 6 or 7. It has to have a 1. So this is 1. This is 6 or 7. This can't be 4 anymore, so this is 8. So this can't be 8. So we have a 6, 7 pair in box 8. So the rest of them have to be 2 and 5. Since this is 2 and 5, we know all 5 of these digits on the diagonal must add up to 19. These already add up to 10, so these two must add up to 9. So this is 4 or 7 to add up with 9 with the 2 or 5. The 4 can't be here, therefore this must be 7, which forces this to be 2, which makes this 5. So this can't be 8, and it cannot have... We know it's a 4, 6 pair. This can't be 5. This can't be 7. So I think all the X-sum clues are already there. This can't be 2, this can't be 2. So this becomes a 2, 7 pair. So this can't be 7, therefore this is a 2, this is a 7. This is a 2, 6 pair. This can't be 2, so this must be 6, which makes this 2. Now we're just doing Sudoku. This is 4, this is a 6. This can't be 6. This is a 5 or an 8. So therefore this can't be 5. Therefore this is an 8. This is a 5, which forces this to be a 7. So that becomes a 1. This can't be 1. This can't be 7. This can't be 1. Excuse me. This can't be 1. So we have a 6, 8, 6, 8 pair in row 1. So the rest of the row can't be 6 or 8, so therefore this is a 5, which makes this not 5 or 6, so this is 1. This has to be 6 or 8. It can't be 5, 6, so this must be 8. which forces this to be 6, and therefore that's 8. This is 4 by Sudoku. This is no longer 8, so this has to be 6, which forces that to be 8, which forces this to be 6, which makes that a 5. So this can't be 6. This can't be 6, so this is 7. This is 6. This can't be 7, so this is 8. This can't be 8, so this is not 8. This is 6. This is 8, which forces that to be 6, which forces that to be 8. And we have a 4-7 pair. This can't be 4, so this is 7. This is 4. And that's a solution. Thank you for playing. Thank you for setting this one. Yeah, I don't know. I think I'm a little slow today. I'm just not... I'm just a little tired, I think. Anyways, I hope this wasn't that slow for you guys, and I'll see you next time on Frank Puzzles. Take care.